Trigonometric integrals can be a little tricky the first time you see them, simply because there's multiple different ways to approach a problem. Like most things in math, practice will help. Practicing will help you see which techniques we need to use to begin each integral. In this video, we'll be focusing on powers of sine and cosine. In general, with these kinds of integrals involving sine and cosine, we want to write only one sine factor and the remainder of the expression in terms of cosine, or only one cosine factor and the remainder of the expression in terms of sine. One of the techniques we use is the trig identity sine squared x plus cosine squared x equals 1. Let's rewrite this original integral and factor out a single sine x, which means we then have sine squared x dx. We can rearrange the trig identity over here to get sine squared by itself. Sine squared x is 1 minus cosine squared x, which means we can rewrite the original now as sine x times 1 minus cosine squared x dx. Next, let's make a u substitution. U we'll call cosine x. Then the derivative will be negative sine x. Notice that cosine occurs in the question, so that's why we call u cosine x. And then sine x also occurs, but it's not negative sine, it's positive sine. So over here we'll need to divide by that negative sign to get sine x. Now rewriting this original integral, we have in parentheses 1 minus cosine we called u, so that's 1 minus u squared, and then sine x dx is negative du. So we'll have du, and I'll pull the negative out front since it's just a constant. Now that we've made a substitution, we have a much simpler integral. The integral of 1 is u. Make sure we distribute the negative sign. So that's negative u. And then the integral here, we get negative negative, which makes that a plus 1/3 u cubed plus c. Replacing the u now, we have negative cosine x plus 1/3 cosine cubed x plus c. In this example, we have cosine to the 5th x. We again want to use the Pythagorean identity, sine squared x plus cosine squared x equals 1. Let's start by rewriting the integral as cosine x times cosine to the 4th x dx. This time we're replacing the cosine, so if we solve the identity for cosine, cosine squared x equals 1 minus sine squared x. So we have cosine x, and I'll show an extra step here. You may see this automatically. We have cosine squared x squared dx. So that is now the integral of cosine x times, replace cosine squared with 1 minus sine squared x, and that quantity is being squared, dx. We again want to make a u substitution. This time let's let u be sine x. Then the derivative will be cosine x. We have the integral of 1 minus, replace sine with u, that is squared, the quantity is squared, and then cosine x dx is the du part. From here we can simplify we have a binomial squared. So we want to square the first. 1 times 1 is 1. Double the product. 1 times negative u squared is negative 2u squared. And then square the last term. That will give us positive u to the fourth du. Now integrating, we get u minus 2/3 u cubed plus 1/5 u to the fifth plus c. Finally, we can go back and substitute in what u is. Recall that we called u sine x. Sine x minus 2/3 sine cubed x plus 1/5 sine to the fifth x plus c.